Hey guys, another video, and this time, as the title suggests, I'm gonna start sharing something that I've been working on for a few weeks now, an idea that came up at work. It started off very raw and very basic, so I didn't want to make a dedicated video up until now. I mentioned it briefly in a few previous videos, but it wasn't at a state where I was like satisfied and I said that yeah, I can make a video and explain things about it. But I've progressed through the couple of weeks, tested different versions and tested the electronics, the basic idea of what I want to make, and it all works fine. So I'm progressing with it, and I'm making a better device and better circuitry to slowly get everything going the way that I wanted to. So to cut it short, let's start off with some basic theory so that we understand what this whole project is about. Some of you that watched the previous video might have seen this already, but this time I'm going to cover it so that we have everything. Basically, at my workplace, we make these support beams. This is the support beam. If you don't know what these are, then I'm going to add some pictures here from off Google just so that you know. But they're used in construction, buildings, warehouses, everything that you can think of that it's made out of steel and is a construction will have these support beams in different sizes. Some of these beams, they come out standard size, like from the factory where they mold the steel. It will be pressed into a shape with the standard size and thickness and all that. But for other customized solutions and different buildings that needs to hold different loads, they need they need to make the top plate thicker or the bottom plate thicker or the whole thing to be customized. And that's where we come in, and what we do is we take 3 plates and different thicknesses from 10 millimeter up to 50-60 millimeter, put them all together and produce this support beam. Now in most cases, these support beams that we produce, they require some additional components on them. They require all kinds of reinforcement plates or plates where another beam will bolt into. They require holes to be drilled in them so that they can pass steel rods to set them in the concrete. Anchors will need to be added for like at the bottom side. So like every 200 millimeter, 300 millimeter, an anchor will be welded onto it. And all these things need to be added. And all these things to be added, they come out of a drawing. There is a plan. An engineer has planned this whole thing. But the basic idea is that a metal worker, the guy that needs to do all these things, which is me, needs to take a measurement for each one of these things. We need to measure the whole length. And according to the plan and the measurements, we make markings. And then we add all these elements on the support beam. So since I'm new to this kind of work and I've just started it recently, I was thinking one day, why couldn't there be like some sort of a cart that rides along the beam? It doesn't have to be metal. It can also be like wood, like a wood. Long piece for construction, aluminium, whatever, anything that is long and it has a constant width and it needs to have measurements on it. Why can't there be like some sort of a cart that travels along it and gets the measurements from some database? Some planner sat before that, he analyzed the whole drawing and he placed all the measurements in some database, and then the cart will travel along, measure, and at each measurement it will set a marking of what needs to come on that place. And that saves a lot of time for the metal worker that basically needs to analyze the whole drawing and then place each measurement on this beam. So that is the basic idea that I had, thought. And I thought, well, I have some skills, so why not try to make something like that and record along the way my progress. I don't know what will come out of it, but it's worth a try and I enjoy doing it, and it's also good content for the channel. So I thought, again, why not make this cart that travels along, takes a measurement, and wherever it needs to, it places a mark. It can have different levels of complexity, from a cart that will have a unit on it, an electronic unit that can communicate with a network and get things out of a database and all that. But the basic goal now at this starting point is to have a cart that can travel along the beam relatively smoothly, straight, with no interference in the way, no unbalancing, no things like that. And it can carry some sort of an electronic circuit that will take a measurement, and then with this pen mechanism just place a dot. That's it. That's all I want to achieve at this point. I can center this unit so that it will go in a straight line, like in the middle, and it needs to place a dot every X millimeter that I'm going to set the program to do so. That's the first goal that I want to achieve, and this is what this whole project is going to be about. Here I've made a sort of rough schematic of what I see this device like. It's going to be some sort of like a meter, like you have digital meters. It will go out, it will just pass through a sensor, and the sensor communicates with the circuit, and everything else happens. But this is the idea. This is the thing that this series of videos is going to be about, and this is part one. So to start with, I started off with just making a cart and seeing how it works and testing different electronics and different ways of that I can measure it. And I'm going to show you the first version of this cart that I've built, which is this one. And you can see it's very rudimentary. I made it in like half an hour. I didn't even bother to like scrape off the paint before I tagged it here, and just use scrap metal to fill in the gaps. These wheels, they're just pulleys. You buy them, you know, to like hang wash and on a wash rack. And these are just shafts out of a printer. And here I've added some mechanism, and this mechanism, the cart basically traveled like this. And I've placed a motor here, just hanged it, just like you see here, with all these fasteners, this tie zips. And I ran the motor, it drives the cart, it pulls it. But this cart is a piece of crap. It's again, I made it in half an hour just so that I can test the electronics. It's not straight, it's wobbly, it's unbalanced, it does this and does that. And if I was smart enough to make some sort of a video about the testing of this, then you're gonna see this video around this time. But this is how I started, and the cart just sat like that, and I've placed like a bunch of electronics here, and the whole measuring mechanism that I've come up with. It's the only one that I have here, but we're going to discuss it later. And the cart traveled like that along the beam, and it took a measurement, and the measurement was relatively precise. Whatever was not precise, moments that I didn't get the desired precision out of it, I've sort of disregarded the electronics and placed it basically on this cart, since it's unbalanced and it wobbles and it does all these movements that cause the electronics to give a false measurement. So this was the first card, and after I've seen that the electronics, they work and everything goes as it does, I thought, okay, well, the next step is to make a better cart, a cart that is reliable, that I can adjust up to 1 millimeter, that is balanced, that travels nicely on the beam. And this weekend, the last week, I finished it. I made it at work, and let me just show you this one, which is right here. It's a more sizable unit, so I'm going to be careful here with the camera and everything, but I'm going to show you a demonstration. But this is basically the new cart. There, you can see it like that. It's I made it out of 2 threaded rods. They're M8s. They're not straight. Everything, all the material here is just off-the-shelf stuff that I've bought at the local home repair store. So these wheels, this strip of metal, the nuts, everything is from this just do-it-yourself store here locally. These shafts, threaded rods, they're not straight. Here there is a small bend in the rod, but it's much it's more stable. As you can see, everything I can adjust it to maybe 1/10 of a millimeter. It's all squared, everything is squared, and everything is stable. This cart is lower, so it has much more balance. So the center of weight, the height of the weight is much lower, and the cart will not do things like that. And I tested it at work, and you can just send it like 6 meters at a very relatively high speed, and it will just stay balanced and accurate and will travel in a straight line. The wheels, again, there are sort of pulleys that you use for like a hanging wash device. Yeah, so the string would come here and you can just pull the string and hang the wash. That's it basically. These wheels, these threaded rods, and this little thing that I made here, which is just tacked together and forms the base where I can place the electronics, the measuring mechanism, basically a whole box that will sort of just sit here, and then it will be separated from this unit. So if this unit, anything happens to it sometime, it breaks or anything like that, you can just take the box, place it in another unit, and you can just carry on working with it. That was the basic idea. So what I'm gonna do now is I'm gonna change the shot, because I can't fit here everything inside the frame. I'm gonna do it on another table, and we're gonna see how it works and how the idea of mine goes about. So hang right in there and I'll be right back. Okay, so we're back, and here we can have a look at what this whole idea with the cart looks like. Now for testing, I'm using this wooden plank that I've got. Saves me the trouble of dragging in a 4-ton support beam into my living room, but it does the job. And again, this thing can also be applied to wood or anything that is long and has a constant width and requires to have measurements on it. So you can see here how the new cart works. I can do this as many times as I want, and the cart will stay stable. Right now this whole thing is not really stable, but the cart itself is stable on the beam. It doesn't wobble, it doesn't lose balance, it doesn't do any sort of movement that might affect whatever sits here on this cart. except for the ride itself on the beam. Now I can tell you from testing that on metal it rides much more smoother because wood is softer, and it sorts of just a little bit sinks, causes the wheels to sink into it, so it's sort of a rougher ride for the kart. But the expectant speed that I'm thinking about is something that goes along like this, and I think that at this speed I can get accurate results, and I can place good markings and do everything without having any sort of interference or abnormalities, unless there is something really radical, like maybe something, a hole or something that would cause the car to like do some sort of a weird movement, which will again cause the electronics to give a false measurement. So you can see here how it works. Here in the middle there will be the electronics. I was thinking at the back here I'm going to put the measuring unit. We're going to see it in a few moments, the idea in either case. But and here at the front there will be the electronics. There will be a drive motor eventually, so just a wheel that is attached not to this cart but to the unit that sits here, and it basically drags the cart along. So the cart just acts as something that holds the unit of electronics, and the unit itself has the motor that sort of pushes it along. So if you just place the box here, then the box would go and start traveling, but this cart sort of keeps it in a straight line and keeps it supported and keeps everything protected from the work environment. So that is basically it. Now next I'm gonna again switch the shot, and we're gonna talk a little bit about the electronics and the measuring device that I made so far. Ideally I would want to use laser, so there will be a laser at the back of this unit that sits here, and here there will be some sort of a backing plate that is mounted on the 0 point of the whatever we're measuring, and the laser basically takes the measurement from that distance. But laser devices, they are expensive. The cheapest ones, they start off, the ones that can actually deliver accuracy, they start off a few $100s, and it can reach well into the thousands for really advanced and precise units. But on that also I will mention a bit more. So let me just go back to the table, and we're going to talk about the mechanism and the electronics that I made so far that are going to sit inside this car. So hang on there and I'll be right back. Okay, so we're back, and let's talk a little bit about my idea of going about measuring and going about doing well the electronics part of this card. So you saw at the video when I was explaining about the first card, you saw that I already made the Arduino, the LCD, and the whole thing. That is sort of trivial, so I'm not going to talk about that too much until I'm at that stage where I can show you something working. But let's see so far the mechanism that I want to use. So again, if you look here, I had this rough idea of making this sort of housing, and it will have a sort of meter device in it, and it will go through a sensor, and it will then provide the reading to the Arduino, and it will deduce the measurement out of it. So for that, what I did is, with my recent discovery of ordering cheap stuff from China, I've ordered 2 of these 1 meter measuring tapes. They're really cheap. I ordered 2 of them, and when I've placed one next to the other, just on a straight line on the piece of wood, they had a difference of about 1 millimeter. But that's not important. I didn't buy them for their measuring capabilities. I bought them for the mechanism that is inside. And what I did is, this one is still the good unit that I just bought in case. The other unit, which I modified, is this one. And I've just placed a small magnet here so that it doesn't accidentally spring back inside, but I don't think that's going to happen. And what I did is I pulled the meter open and I've cut a piece of it and I've placed this encoder strip instead, just so that I can emulate a digital meter and the way that a digital meter will take a measurement. A digital meter will have sort of a validating system. So this is only like a single measurement, so whatever measurement we get comes from this, will come from this strip alone, and we need something that will also be validating it. But this is just for testing. In the last part I mentioned that I want ideally to have a laser unit, and there is one on eBay which costs $50, and they say that it can deliver an accuracy of up to 1 millimeter, so that can be a good solution, a good cheap solution for this sort of thing. It's not going to be a product, it's not something that I'm going to invest and start a whole business around, but $50 to invest and get like a working prototype, I think that it will be a nice investment, and I would consider doing it in the future once I've implemented everything and tested it just with this rudimentary mechanism, which, if provided the right conditions and a good housing and everything, it gives the same measurement, and it can also be made to be very accurate and get good readings out of it, just for testing purposes. So this is what I did with these meters, and there is an encoder strip inside. And this is another unit that I've made it yesterday, and it's rough, but it will do the job for initially. What it does, it just carries the strip inside, so through the slot here there will be the encoder, and the encoder is, let me show it to you if I can find it. Where did I place it? I don't know. It's somewhere around here. But in any way, the encoder, you saw it also in the first small video at the beginning. It will just sit here, and the strip that comes out of this this meter would go through it, and there is a photo that you can see of it right now. And this meter will be like maybe attached here, or I don't know, I haven't thought of that yet. It's still everything, I'm still doing it. I just finished this cart, and this weekend I was working on the mechanism. But basically, if I put this piece of plexiglass, you see I made markings here where I need to cut it, and this will sort of be like that, but it will come here at the middle. So this whole unit will hang on this piece of plastic, and this will be here. It will sit on, like, I will put here some sort of soft dampers or something so that it doesn't sit flush on the metal. And then this meter would sit somewhere here maybe. And this is how I'm going to mount it. To make the markings, I just salvaged out the pen mechanism that I made for the plotter, and it's this one. And it has a whole bunch of attachment that I've done on it just to get it to fit on the previous version. But basically I'm going to remove this piece here, and then out of another piece of plastic I'm going to cut out again a segment, and then stick this on it like that, and it will be about this height. I don't know if you can see it from the bottom. So this tip here would be about 5 millimeter off the surface, and then the solenoid just presses it and it makes a mark. And I also had have this laser module, which again I ordered from China, and it's a cross module. Just ordered it because I initially thought of also maybe implementing some sort of a projection. So as you can see here on this drawing, the support beam, it has a top side and it has a bottom side. You also need to add things, or you need to drill on the bottom side, so from the inside but the bottom plate. And this cart, with the aid of this laser, and if I have enough skill to mount it precisely, then it could give a projection, and then the metal worker will be able to make a mark by himself based on the projection that it gives. But for now, I'm just going to use it to sort of give an effect of a straight line so that I can follow it. And then when I place another meter on the beam, so that I can follow what this does and get to see if I get good results, with this laser I can make a sort of cross line that will also point on the measurement on the other meter. These are the components that I have up until now. And again, the Arduino, the code, the LCD, those are all trivial things. The motor, those are all really things that they're only relevant if I can get an accurate measurement. Once I can get an accurate measurement and I know that this thing works, then I can carry it on from there and do anything that I want with it. And if you think about it, once I can get an accurate measurement, then I don't only stop at making points. Depending on how big I can make the mechanism and how heavy I can make this cart and the whole thing, it can do anything from drilling up to, I don't know, cutting, welding, whatever I can think of that needs to come on a precise measurement. So that was it, and I hope you like this video. And if you have any ideas, things that from your experience better than mine, would say, no, you need to do this differently and maybe do that differently. If it's within my capabilities and it's valid, then I would seriously consider adding it. And I'm always looking for ideas because I'm thinking about all this by myself, and I'm not like an engineer. I don't do these things on a daily basis. So if some of you guys have more experience, feel free to share it. Hope you like this video, and that's it. Thank you for watching, and I'll see you next time.